Welcome to the YouTube channel PCMB Tutorials. I hope you all are fine. Today we are going to learn Class 9th Foundation Subject Physics, Chapter number 2, Work, Power, Energy. And this is our Part 1. The contents of this chapter are work, then power, then energy, then forms of energy, then summary of energy, and then it is the previous competitive examination questions, then brain teasers. We'll see each and every of them. First of all, work, power, energy. The contents will learn work, then power, then energy, then forms of energy, and etc. So let's start. And our first topic is work. Work, physical understanding of work. So in our day-to-day life, the transfer of energy plays a major role. To understand this, let's imagine for a moment that no energy transfer takes place in the world. So there are some examples. First, if there is no energy transfer from the sun to the earth, then life will not exist. Second, if there is no sound energy transfer, then people cannot hear. Third, if there is no energy transfer in automobiles, then there would be no transportation. Fourth is, if there is no transfer of energy from our food to our body, then we will do not survive. Similarly, the list goes on. From the examples, it is clear that transfer of energy from one point to another or from one body to another, we require someone or something. If there is no energy transfer, probably nothing will work in the universe. So now, who is ultimately responsible for the transfer of energy? It can be magnetic wave, mechanical wave, IC engine, crank, metabolism. Overall, we can say that to transfer energy from one body to another, we require mediators like wave, force, etc. To transfer the energy from one body to another. We require mediators like wave, force, etc. In mechanical situations, energy transferred by a force from one body to another is what we call work done by that force. Work done. That is, the mechanical situation, energy transferred by a force from one body to another is called the work done by that force. But in physics, work is said to be done only when a body moves under the influence of a force. Only when a body moves under the influence of force. Of a force. If there is no motion produced in the body, even when a force acts on it, the work done is said to be zero. So, the definition is work is said to be done by a force on a body when the force displaces the body through a certain distance in the direction of force. I'll repeat. Work is said to be done by a force on a body when the force displaces the body through a certain distance in the direction of force. Then there is measurement of work. Measurement of work. The amount of work done by a body depends upon first point, that is the magnitude of the force. Magnitude of the force displaces the body through a certain distance in the direction of force. First is the magnitude of the force and second is the displacement of the body. Displacement of the body. So by knowing the force and displacement, we can measure the work done. The amount of work done is equal to the product of the force and the displacement of a body from one point of application of the force in the direction of force. So the formula is work is equal to force into displacement of the body. Work is equal to force into displacement of the body. Now, there is nature of the quantity. Even though force and displacement are vectors, work is a scalar quantity. Work is independent of time. Work is scalar quantity. Work is a scalar quantity. Then there are units of work. The absolute units are SI unit of work is joule, SI unit is joule, and CGS unit is ERG, energy. Joule, the work is said to be 1 joule if 1 Newton of the force displaces the body through 1 meter in the direction of the force. And energy is the work done is said to be 1 energy if 1 dyne of the force displaces the body through 1 centimeter in the direction of the force. Now, other than this units, work also has units called gravitational units. Gravitational units is SI unit, that is kg weight per meter, and CGS unit is gram weight per centimeter. The relation between joule and energy is 1 joule is equal to 10 raised to 5 dyne into 10 raised to 2 centimeter. 1 energy is equal to 1 dyne centimeter. 1 meter is equal to 10 raised to 2 centimeter. 1 Newton is equal to 10 raised to 5 dyne. 1 joule is equal to 10 raised to 7 dyne per centimeter. Likewise, I hope you've understood the first part. Over here we'll end this first part. In part 2, we will first of all do the summary of units. Then we will see a small story of work with zeal and enthusiasm, James Prescott Joule. Then we will see different expressions to calculate the. We'll see some examples points. Till that, I hope you've understood this first part. For any queries and doubt, please join the Telegram link given in the description of this video. Like, this is the foundation of class 9th. We've covered the foundation of class 7th and 8th too. The links are given in the description. Please go and check through it. Thank you for watching. Let's meet in part 2.